Hello everyone, let's look at gas station. The problem statement is, there are n gas stations along a circular route, where the amount of gas at station I is gas I. We have a car with an unlimited gas tank, and it uses cost I of gas travel from station I to its next station I plus 1. We start the journey with an empty tank at one of the gas stations. We need to determine if we can travel around the circuit once in clockwise direction. If we can, we return the starting gas station index. Otherwise, we return -1. Let's look at example 1. For the input, the gas array is 1, 2, 3, 4, 5. The cost array is 3, 4, 5, 1, 2. The output is 3, starting at station 3, that's index 3, and we fill up with 4 units of gas. In the tank, we have 4. Then travel to station 4, our tank has 4 minus 1 plus 5, that's 8. Then travel to station 0, our tank has 8 minus 2 plus 1, that's 7. Then travel to station 1, our tank has 7 minus 3 plus 2, that's 6. And then travel to station 2, our tank has 6 minus 4 plus 3, that's 5. And then travel to station 5, the cost is 5, and we just have enough gas to move back to station 3. So we just return 3 as the starting index. One straightforward solution is to simulate the driving process index by index and see if starting at this individual index will make the circular travel. Basically, we need 2 layers of loop. Outer layer loop is our start index, and inner layer loop simulate the driving process and see if the inner loop index can reach back to outer loop index. However, this is pretty much a brute force solution, and having 2 layers of loop will make the time complexity O n squared. Can we do it better? I think we can. First, let's look at our gas array and cost array again. I think we can check if the sum of the gas array is less than the sum of the cost array. That means the total gas is less than the total cost. If that's the case, we can confirm there is no solution. We can simply return -1. Let's look at the code. And then we compare total gas and total cost. If total gas is less than total cost, we simply return -1 because we won't be able to make it happen. While we loop through the array, if we use gas I minus cost I, then the value we get is the leftover gas. And then we can get a new array. Let's call it leftover array. This array represents each journey what is the leftover gas in the tank, and we won't make the corresponding journey if the value is negative. Let's look at example 1. What will be the leftover array? It will be -2, -2, -2, 3, 3. And then we can simply loop through this leftover array to simulate the driving process by adding them one by one, and we get the current gas value in the tank. Let's look at the code. By adding individual leftover I together, we get this current gas. This represents the current gas in our tank. If this value is less than 0, it means it cannot make it to the next gas station. It means we can certainly not start from here, and we need to start all over by reset this current gas value to 0 and reset our start value. Let me say this again. For a start index, the leftover start must greater or equal than 0. We must have this condition, because we cannot start from a negative value in the leftover array, because we won't be able to make it to the next station. And every time we add a new leftover value I to our current gas, we are actually stimulating this driving process. We keep accumulating this current gas value. For current gas value turning from non-negative to negative, the index I in the leftover, this value, must be a negative value, because adding this value to our current gas, it makes all previous accumulated positive value useless. So we need to reset our current gas by starting over. So basically we need to redo the accumulation and make sure this current gas should be a non-negative value. And also our start index should be I plus 1, because at any point between the previous start and I, it won't make the current gas value positive again because of this big negative leftover I. And in the end, we can simply return our start. Let's try to submit. It passed. Before we look at the complexity, I think we can optimize the code a bit by consolidating these two for loops. To look at the whole code again, this total gas will be used to determine there is a solution or not, and this current gas represents the current leftover gas in our tank. As soon as the value is less than 0, we need to start over and move our start index. Let's look at the complexity here. It's constant, O of 1. For time, it's also On because we only have this loop once. If you have any question, please leave a comment below. Thank you for watching.